Alright, geometry students, welcome to online lesson with trigonometry, particularly right triangle trigonometry. That's the big thing that we're looking at right now. We're not doing the full-blown trig, but in geometry we will get at least this part of it. Let's go and get started. First thing it's asking us to do is find the value of each trigonometric ratio. The trigonometric ratios are those that acronym that we started learning in class. We have the SO, and then the Ka, this is an H here, and then To. And what these actually represent is sine of an angle, we could call it theta, equals the opposite side over the hypotenuse. Then we got the cosine of an angle equals the adjacent over the hypotenuse. And then the tangent of an angle is going to equal the opposite over the adjacent, and that's all summed up in this little acronym. So for sine is opposite over hypotenuse, Ka, and Toa. So let's look at this first one. It says tangent of z. Well, first we got to see, where is z? Where is it? Well, I look around the triangle. Here it is. So this is my angle that I'm concerned with. If that's the case, then I can name these three sides in relationship to their position compared to the original angle, z. Well, this 27 across is going to be our opposite because it's across the triangle. It's opposite the angle. The 36 is the leg that's next to it, so that's the adjacent leg. And then the hypotenuse is always across from the right angle. So that's how we would label the sides for this particular triangle. So when it's asking us tangent of z, well, that's going to equal tangent is Toa. So we need the opposite on top and the adjacent on bottom. So that ratio would be 27 is our opposite, and 45 is our, oh whoops, not 45. Pardon me on that one. What's our adjacent? It's 36. 36. So this is 36. That's our adjacent side. Now this would be a fine answer for a free response type question. However, if you're doing a multiple choice test, we would need to simplify. I noticed that 9 goes into each of these, so I'm going to divide the top and the bottom by 9, and it would simplify to 3/4 or 3/4. Alright, that's one. Let's do a couple more of those just to kind of get some good practice here. Remember, you can slow down, pause, speed up the video as much as you want, but I'm just going to kind of go at my own pace here. So now we're looking at cosine of x. Well, in this case, it looks like x is here in the corner. If we're talking about cosine, remember we got so, ga, to. That means that we're looking at cosine. And cosine of x is going to be the adjacent side over the hypotenuse, because that's the ka here in the middle. And the adjacent, in this case, this would be our adjacent, and this would be our hypotenuse, because adjacent is next to the x, and the x happens to be down here. If it was the z, then it would have been the 8 was adjacent, but that's not what it is. It's the x. So if it's angle x, then here's our adjacent, and here's our hypotenuse. So that ratio is going to be 6/10. When we simplify, that would be simplified to 3/5. That would be our multiple choice answer. 6/10 is just a fine answer as well. Sine of c. So now we're back to sine. Well, that's the SOH. Sine of c equals, well, we need to look at the opposite side over the hypotenuse side. The opposite side is going to be 15. It's over here. This is our opposite because it's opposite angle C. And then the hypotenuse is 17, of course, because it's that diagonal line that's opposite the right angle. This cannot be simplified, so we're done with that. That's enough for that one. Let's look at this. Alright. These ones, pretty much the same idea. The triangle is just kind of moved around a little bit, so now we got to really find the right orientation, figure out where we are. We're talking about cosine of c. So I'm going to write this SOHCAHTOA just because it's helpful every time. The more I write it, the better I learn it. You should write it as well. Cosine of c. So we're looking at this angle. That means this side is adjacent or opposite. This side is adjacent. And of course, across from the right angle is the hypotenuse. Cosine of C is going to be the adjacent over the hypotenuse, which would be, in this case, 15 over 39. Now, it's not exactly obvious, but both of these are divisible by 3. In the top, 3 goes into 15 5 times, and 3 goes into 39 13 times. So 5 over 13 would be our final answer on a multiple choice test. This next one I'm going to do in red, just to add some contrast here. Notice that we're looking at angle A. So that's the one that we're going for. That means from angle A, the 12 is now opposite, the 9 is adjacent, and the 15 is our hypotenuse, of course, because it's across from the right angle. So the cosine of A is going to be the ka, which is up here. That's adjacent over hypotenuse again, just like we did before. The adjacent side is 9, and the hypotenuse side is 15. It really helps if I label it first with each of these pieces, because then I don't have to think about it. I just kind of follow what I've already written. To simplify 9 over 15, we can divide top and bottom by 3. We'd get 3 on top and 5 on bottom. That would be our final simplified answer there. Keeping the pace going here, I'm going to go to the next one. Alright, now we got some calculator work. It's asking us to find each angle measure. This is going to imply that we need to do a tangent, sine, or cosine inverse. It's going to be that extra button. So as I'm looking at this, I see that tangent A equals this number. Well, if I take tangent inverse of both sides, on the left side, that's going to reverse the process of doing tangent. So it's just going to be A on the left side. But on the right side, we're going to have tangent inverse of 0.9657. Let's simplify that just a little bit more. So I need a calculator to help me calculate this. A couple of things to check. We know that we're in degree mode here, not radian, because in geometry we tend to use degree mode for the most part. So I'm going to make sure that I have that checked. Next thing, type in the calculation. This is tangent inverse. So I'm going to do second and then tan. It gives me the tangent inverse. And then I'm going to type in this decimal here, 0.9657. Close that off with the parentheses and plug. I think it's 44. So A equals 44 degrees, of course. Now let's do the other one in blue, just to kind of separate the problems here. It says cosine of C equals 0.9613. So similarly, that means that cosine inverse of 0.9613 is going to equal C. Well, let's type that in and see what we get. That means we have second and then cosine. And this time I'm going to type in, what's the numbers again we have? Let's see, it is 0.9613, 0.9613. Type that in, and we get 16 degrees. So this equals, C equals 16 degrees. Knowledge, those are pretty easy. It's just knowledge of usage. All right, so now we're going to do something where we find the measure of the indicated angle. Looks like we don't have an example. Let's go to the next one. All right, so for this, we have an angle here. This question mark. That's what we're really looking for. This question mark. Okay, so we need to figure out that question mark. And we have these two sides, a 49 and a 46 for each of those sides. Let's not cross out the numbers, let's just circle them. So we have these three pieces. We got an angle, then we have the opposite side, and we have the hypotenuse side. And if that's the case, I already have the ingredients that I need to make my little trig recipe. So let's go back to our cookbook, which is just this general template. So, ka, to. Well, looking at these three, which one fits? Which one has an opposite and a hypotenuse? That would be sine. So that means that sine of this question mark is going to equal 46 over 49, the opposite over the hypotenuse. I could simplify that if I need to, but I really just need to translate it into an inverse sign. So I'm going to do sine inverse of 46 over 49 is going to equal the question mark, the angle that we need. This is the angle that we're trying to find. Well, let's go ahead and type the second sine and type in the fraction 46 divided by 49. See what we get. 0.69846. And say it's 70. So the question mark right here, this is about 70 degrees. Let's change colors again. Let's go back to black. So now we have this angle, this side 29, and then the other side 9. So if I look at two sides, 9 is actually the opposite side. 29 is the adjacent side. So which of the three am I going to use? It looks like tangent. That means that tangent of the question mark is equal to the opposite, which is 9, over the adjacent, which is 29. That can lead us to translate this into an inverse trig. That means that tangent inverse of the fraction, 9 over 29, is going to equal our question mark. Let's see what we wind up getting when we do that calculation. So we're going to do tangent inverse, this time 9 divided by 29. Close that off. And it looks like we get about 17. So this question mark right here, this is about 17 degrees. A lot of this is calculator work and just being really comfortable, extremely comfortable with the SOHCAHTOA process, the template, the little design that helps us set up these relationships. Let's try a couple more. If you want, go ahead and pause the video and try these and then see if you get them right after we do it. All right, now here we have choices, and sometimes choice actually makes it harder because which two numbers do we use? Well, the answer is kind of weird because it doesn't really matter. You just have to use two. Well, I'm just going to choose these two here. And then I'll choose a different two for the next. So because I chose those two circles and this angle is the one that they're asking, that means that this 28 is my opposite and the 35 is my hypotenuse. Well, let's see. I need my template here. We got SOHCAHTOA. Alright, so we got SOHCAHTOA. And it looks like we have the opposite in the hypotenuse. That means that I'm going to have 28 over 35 is equal to sine of that question mark. Well, we can translate that again. That's going to be sine inverse of 28 over 35 is equal to the question mark. Let's calculate it. So we're going to do second sine inverse, this time 28 divided by 35. We type that in and we get 53 degrees. So the question mark equals 53 degrees. Right here, this angle is going to be 53. Now on the bottom, let's do this in a different color. Let's go back to red. We have this question mark, and this time I want to use this 35 and this 28. I'm going to be using the same numbers, but notice it's actually going to give me a different answer. It's kind of weird. So this time the relationship, we're going to have the hypotenuse and the adjacent. So I have the hypotenuse and the adjacent. That means I'm going to use cosine. So cosine of a question mark is going to equal the adjacent over the hypotenuse. And the adjacent is 28. And the hypotenuse is 35. Now these two look very similar, but notice that the trig relationship is different. The first one was sine, this one's cosine. So that means that our actual answer for the angle should be different. Let's look at that. That means we have cosine inverse of 28 over 35 equals the question mark. Go to our calculator. That means second cosine. We're going to do 28 divided by 35. And that means our angle is about 36 or 37. I'm going to go ahead and say, round it up and say 37. So that means the question mark equals 37 degrees. So down here, this question mark equals 37 degrees. Let's try another one. Find the missing side. All right, now we're going to use these relationships in a way where we can find not only angles but also sides. So let's go ahead and start with what we have here, the pieces that we have. Looks like we have an x, which is our hypotenuse. We have a 20. This is our opposite because it's opposite the 15 degrees there. And this angle. So if I start with my template, so, ka, toa. The opposite and hypotenuse again is going to be using sine. That seems like a pretty common one here actually. So sine equals sine of 15 degrees, because it's sine of the angle, equals the opposite, which is 20, over x. Well, I got to get this x by itself, so let's see what we can do. I could multiply both sides by x. The x over x simplifies, and I'll just have 20 on the right side. On the left side, though, I'm going to have x sine 15. I got to get rid of this sine 15 and move it over to the other side of this relationship. That gives me that x equals 20 divided by sine of 15. Now that's a proper answer. That's actually very exact. But let's find the decimal approximation because it's asking us to round it. And that's probably what it's going to ask you on your test as well. So I'm going to do 20 divided by regular sine this time. I'm not going to do the sine inverse, just sine of 15 degrees. That gives me about 77. So this x right here equals 77.3. Alright, let's take a look at 53. This one we'll do in blue. So we have this angle 68. This 13 is the opposite side, and this x here is the adjacent side. So looking back at my relationships, I have tangent. Tangent is the blue one that we're going to do. So tangent of 68 degrees is equal to the opposite, which is 13, over the adjacent, which is x. Now again, I have that x in the denominator, so let's work our way through this. We can multiply both sides by x. And then we could also divide by tangent 68. That gives me x equals 13 divided by tangent of 68. So let's figure out what that would approximate to using our calculator. 13 divided by tangent of 68. That gives me 0.25.3. So this x right here is about 5.2. I'm going to go ahead and leave it rounded down. You could say 5.25 if you're really picky. It would be pretty clear from the multiple choices which one is correct. But just kind of keep in mind that you really just want to get close enough so that you're choosing the right answer. Let's do a couple more, a lot like that. These triangles aren't exactly in the normal orientation. A lot of times we see triangles, you know, with this kind of shape. These ones aren't like that, so we got to be careful and watch the pieces and how they relate to everything. Well, first of all, look at this 73 degrees. It almost looks like it could be in either corner here. I do know it's in the bottom right corner because this up here, this is 90 degrees. That's 90 up in the square corner. So that means this 73 goes down here. So I got this angle, and then this 15 is the adjacent leg to that angle, and then this x is the hypotenuse because it's opposite the 90 degrees. That means that I have, well, let's look at my relationship. So, ka, toa. I got the adjacent and the hypotenuse. That means I'm going to be using cosine for the first problem, number 63. So we got cosine of 73 degrees is equal to the adjacent over the hypotenuse. And that means the adjacent is 15 and the hypotenuse is x. Again, we have this kind of format where we got an x on the bottom I'm going to give myself some space here to solve this. So move the x over to the left side by multiplying both sides by x. I'm going to divide both sides by cosine 73 to move that as well. So we have cosine 73 and then 15 over cosine 73 on the other side. Well then, let's see what that would approximate to. 15 divided by cosine 73. That equals 51.3. So x right here equals 51.3. Alright, let's look at this next one. We have, let's do it in, how about green? Let's go back to green. We got this x, this 45 degrees, and this 15. Well, from this 45 degrees, the x is going to be opposite, and the 15 is going to be the hypotenuse. So if we're looking back at our relationship, that's actually going to be the SO, or the sine relationship. That means that sine of 45 degrees is equal to the opposite, which is x, over 15, which is the hypotenuse. To get that x by itself, we're going to multiply both sides by 15. 15 over 15 simplifies, and we just have 15 sine 45 degrees equals x. Let's calculate that. 15 sine 45 degrees. And we get 10.6. So x right here equals 10.6 as a decimal approximation, of course. I should say approximately equals 10.6. Let's try another one. Alright, now here's the Big Daddy problem. This one has a lot going on in it. And I'm going to kind of break it down for you guys in multiple parts. So the first idea is that we can separate this shape into triangles. So I'm going to start by drawing. Let's see if we can get this to come out. We need some black lines. This will be a black line. There we go. So I'm going to start by drawing and trying to split this up into equal triangles. I know my lines aren't going to be perfect, but you guys will hopefully see kind of where it's coming from. Now, because this is a regular polygon, I know we kind of skipped around a little bit here, but when you hear the word regular polygon, whenever it says regular, that means that all these sides are the same. They're all congruent. And all these sides in the middle are actually going to wind up being the same as well. So I wind up having a lot of just one triangle over and over and over again. That means that I got 1, 2, 3, 4, 5, 6, 7 triangles. We have 7 triangles. And when it's asking me to find the area, if I just find the area of one triangle, and then I multiply that times 7, that equals the total area. So that's what we're going to do. We're going to find the area of one and then multiply it by 7. And you're probably thinking, there is no angle, there's nothing. Well, we can kind of figure it out. So let's start with shape here in the middle. See if this will help us out. It's actually a little dark. Let's fill that in with maybe like a yellow. Oh, wrong way. Let's swap those colors. Black on the outside, yellow on the inside. That's pretty close there. Alright, so that's the triangle that we're going to find. Notice that this bottom here, this is 8. We don't know these two sides, but that doesn't really matter. To find the area of one triangle, the area of one triangle is just half the base times the height. Well, we know the base. It's 8. So we really just need to know what is the height. What is this height right here? Well, that's going to come from splitting this up into its individual piece. What I'm trying to say there is we got 7 triangles. We want to focus on one of them. So let's find the measure of just one of those triangles. Well, notice that these angles all the way around, there's 7 of them, and they're all equally spaced. That means that if I took this full circle and split it up into 7 pieces, I would get just one of them. I would get this angle right here. Let's see if we can figure that out. That looks like the full circle would be 360. And then we're dividing it into 7 pieces. Well, what would that equal? Well, as we have one, 360 divided by 7. That comes out to 51.42 about. So let's say, how about we'll round it up. We'll say 52. Close enough. It's 52 degrees. Well, then let's look at these angles down here. This one in the bottom and this one in the bottom as well. And because notice that we have some symmetry in each of the triangles, that means that they're actually isosceles triangles. And isosceles triangles have, pardon me, they have equal bases here. Well, if this is 52 up in the top, total these 3 angles are going to add up to, pardon me, they're going to add up to 180. So we know that angle C equals, if I were to label this ABC, just to help see what we're doing, angle C is 52 degrees. And I know that angle A plus angle B plus angle C is all totaling up to 180 because that's the inside of a triangle. And I know that angle C is 52. I also know that A and B are the same, so I'm just going to replace B with one of these A's. It's going to be 2 times, actually, you know what? We don't even need to do that. We'll get to that after we start moving this 52 around. We got angle A plus angle B plus 52 equals 180. So I need to then subtract 52 from both sides. If I subtract 52 from 180, that's going to give me 128. And on the other side I have angle A and angle B. But notice that these two are the same angle. They're the same value. So I got 2 of the same equals 128. Well, if I split that in half then I can just get one of them. Angle A would equal 64. So here, this is 64 degrees and 64, not 69. Then we got 64 here as well. If I were to add that up, I would get 180. Alright, so much work just for a little bit of something. And we're not even quite finished. So let's actually make this bigger so you guys can see what's about to happen. I'm going to snap a shot and put it so we can see everything that's going on. New page. The problem that we're working on. I'm going to make it bigger so we can see the details a little bit better. So I'm going to mark this up in blue with a dotted line down the middle, and that's our height. That's what we need to find. Why do we need to find that? Because the area equals half the base times the height, and we know the base, but we don't know the height. That's a question mark for us. So this triangle, if I split it in half, this 8 is now 2 pieces of 4. So I have a triangle that's got 4, and then it's got 64 for the angle, and I want to know this height. That's actually a trig relationship. If you think back to what we've been working on this whole time, so, ka, to, that looks like I have the adjacent and the opposite sides. So I'm going to use tangent. That means tangent of 64 equals the opposite, the question mark, over 4. So to solve this for the question mark, I'm going to multiply both sides by 4. That gives me 4 tangent 64 equals the question mark. So now I am almost there. I know you guys are losing focus probably. It's just like, oh my gosh, when does this problem end? It is so close, 80% of the way. 4 tangent 64 is the calculation we need. Let's see what we get. If we type that in, we get 8 equals 8.2. That tells me that this height is 8.2. And the base is 8. So I got this triangle. The area of one triangle equals 1/2 the base times the height. And the base is 8, and the height is 8.2. So we got 1/2, 8 times 8.2. I'm not even going to chance it. I'm going to go straight to my calculator. So I'm going to times that. I'm going to do 1/2 times 8 times 8.2. Let's see what we get. 32.8. So this area equals 32.8. That's for one triangle. How many do we have? Well, let's take a look. 7. Is it 7? Oh, that's a different problem. Here we go. We had 7 triangles. One triangle equals 32.8. So 7 triangles, how much would that be? Let's multiply that answer by 7. 32.8 times, whoops, we got to go back one and change this division to a times 7. There we go. Press enter. 229.6. The answer is 229.6. Now the units in this case is feet, so we're talking square feet or feet squared. That's all we're going to do for this video. If you guys need additional help, please feel free to ask questions in class, or you can comment below if you find any errors or you have any additional questions. Thank you and have a good night.